program to be executed when interrupt has occurred. Yes. Okay. No Ganshu, 16 hours for 16 hours. Okay. Okay. Right. Tomorrow I'm taking one special class on what we call this 2021 paper analysis. Okay, we'll talk on that. Don't worry. Now come here. Notification also. Listen. So this is what we discussed already yesterday class. 8085 microprocessor is a 40 pin IC. Sushil plus sorry, special class on Academy. For two sessions I'm taking, one in English and Telugu. We'll talk on that after the end of the class or tomorrow. We have time in it. 40 pin IC, it contains 27 output pins, 21 input pins. You add together how much it is? Good evening, Sura. What is 27 plus 21? 48, right. Who is that 49 guy? Amitabh ji, good evening. So 48 is more than 40. How to manage this 40 and 48 we'll discuss on that. Don't worry, just wait. So 8 pins are common for both output and input. That we discuss. Okay, that is because of the multiplexing of the pins. Because you cannot accommodate more number of pins. So we do the concept called multiplexing. We discussed that. Vedika Singh, good evening. So it is made by endpoint. These things we have discussed yesterday. It is having different various. 5 MHz is also there. So 3 micrometer technology. Currently it is in nanometers right now technologies. So the chip contains around 6500 transistors. Power supply required is 5 volts. It is a 8-bit data bus, 16-bit address bus. Okay. All those yesterday last lecture I already told you what is the meaning of address and data bus. So good evening Aishwarya. So now let's discuss the next part. Now we are slowly entering into 8085 microprocessor. In that first we are going to discuss called bus structure of 8085. Yes, Kumari, because it is an integrated circuit. Okay, so this is the bus structure of the 8085. See here, listen please. Here maybe some typing error, don't worry about it. Come here. 8085 contains 3 buses. Data bus, address bus, control bus. Okay, let me clear that doubt. Mari, please see here. This is what we call integrated circuit. Because of this only your mobile phone is this much size. You have lakhs of transistors on a single chip. Okay, because of this VLSI technology we are having, this is possible. So you see the size. Okay, it is not the size of IC. Okay, it is the technology size, that what we call thickness of the layer, thickness layer. Okay, so right, this is very less. Right now we are going with millions, almost lakhs. Okay. To study VLSI, you will be knowing it much better also. Yeah, Shivam, you will be studying that. Okay, let's come to this class. So Your 8085 contains three kind of buses: address bus, data bus, control bus. Now immediately first people will find a difficulty in 8085 because of terminology. I already told you na. First thing you will feel difficult is what is bus, sir? What is bus? It is nothing but a group of wires. A group of wires or lines. Bus will carry all the people. Na? Similarly, this fellow will carry all the lines. So each line will carry some data or the address. Is it clear what is the meaning of bus? A group of wires is called as bus. Simple meaning. Now let's understand. Let's understand here how this data bus is, how address bus is, how control bus is. So coming to data bus, your data bus in 8085 is 8-bit. Okay, it is 8-bit size. Just 1 minute. I don't feel what we call. Okay. So now your data bus size is how much? 8 bits. Your processor CPU length or the what we call the size 8-bit processor, 32-bit processor, like that we speak, that is decided by the data bus length. Based on the data bus only we decide the processor length. Okay. So 8085 contains 8-bit processor. That is all its registers are 8-bit size only. All operations performed in general are 8-bit only. That is the meaning. Okay, its ALU capability is also 8 bits only. It is bidirectional. What is data bus? Data bus is bidirectional. Why bidirectional, sir? Because it can read and it can write also. So data bus must be compulsory what? Bidirectional. Just wait. No, Ganesh. Maybe tomorrow. I'll tell you before that. Okay. Right. Listen here. This is about your data bus. The processor length or the data handling capability of the processor is decided by whom? Data bus size. A n-bit processor contains n-bit data bus. Its ALU is capable of performing n-bit operations at a time. So if I say 8-bit processor, okay, 8085 is 8-bit processor. So its data bus must be 8 bits. Address bus can be 8 or 16, doesn't matter. It can be any size. Who will decide the processor bit size is decided by whom? Data bus. So who will decide it? Data bus. So 8085 is a 8-bit data bus. It is a bidirectional bus. Multiplexed means multiplexed with lower order address bus to save the number of pins. Why are you worrying, Sushil? Let me complete first. After that, I don't keep any doubt with you. So here, listen. Your address is containing how many bits? 16. In that 16, you take it into two parts, A15 to A8. One part, A7 to A0, another part. This is a higher order and this is lower order. Your data bus also, so the same pins will be used for both address, lower order address and data also. Is it clear? So the same pins of your chip contains 40 pins. If you use 16 for this, 8 for this, total 24 is gone already. So number of pins constraint is there. You cannot increase the pins also. So there is an advantage if you go for multiplexing. That is using the same pins for both address and data. So if you use it, is there any disadvantage? No disadvantage is there, because see here, you have memory. Okay, first what you keep? You keep the address. Then the particular data will come out and read it. So first you are keeping address, then you are taking data. So both will happen not at a time. Okay, both are not happening at a time. So you are using the same pins for both address and data. That is what we call multiplexing. You are using, for example, what is the multiplexing meaning here? You are using two. Out of the two, you are selecting one. Out of the address and the data, you select one according to your requirement. Same as your marks. Okay. Any doubt, please ask. Let me drink some water. No, Rahul, it is not possible simultaneously data and address. Simultaneously address and data is possible. Same line cannot act as address and data. Okay. Say, I will tell you little extra also if required. You have the chip. These are the pins. Okay. These are the pins. In that 8 pins we take. And here we use one latch. Okay. So like that. You have a latch. For that you give 8 pins. You have one enable signal. And these 8 pins will be taken like this also parallelly. Now what happens is, when I make enable equal to 1, I will keep address here. That address will come here. Then I will make enable 0. I will make enable equal to 0. Then what happens? Whatever present here will not come here. Now I use these lines for data. Okay. Say I have n number of lines. It can be anything. You have one latch, 8-bit latch. Here I give enable. First I keep address. Process is like this. Give enable. You get the address outside. Then you take these lines. Now use it for data, because this address will be as it is. Enable is made equal to 0. Even this line, these inputs are now changed. No problem, na? So this is how the hardware will be designed. One minute, please. One minute. Someone asked some doubt. Sir, why are you only capable of n-bit operations? I didn't understand your question, Arjun. Please ask clearly. Why ALU is only capable of n-bit operations means, what do you mean by that n? Yeah, a n-bit processor contains n-bit data bus. Says your processor is capable of performing n-bit operations at a time, ideally. So ALU is also capable of doing n bits of operation at a time. Okay, you have 8-bit processor. What does it mean? You can read 8-bit of data, write 8-bit of data, and also you can add 8-bit of data ideally at a time. Okay, fine. So next go to the data bus. Sir, what is your doubt, Krishna Reddy? Sir, data and address contain same information. We are using it for both. I didn't get you. Data and address does not contain same information. Na? Address contains where destination. Data contains information. Lines are same. That is what is the meaning of bus is common? For CPU, for your processor, whatever the hardware pins are there, na, these pins are common. Not same bits, same pin, same lines are used for transferring the address and also data. We are using the same lines to transfer the address and also data. Okay, now let's move. Bidirectional and multiplexing is not related. That I am saying data bus is bidirectional because data can be read and write also. Okay, next. The next one what we have is address bus. Next one what we have is address bus. Listen here. Address bus is unidirectional. What is address bus? It is unidirectional. Why? We just give the address na. Through address lines, we just give address to the memory device. Okay. Then it should be only single directional. Okay, maybe 8 bits multiplexer will be bidirectional. The remaining higher address, intention of address is unidirectional. So how much size is the address bus in 8085? 16 bits. Last lecture I told you what does the meaning of address bus size 16 bits? It is having 2 power 16. It can address 2 power 16 different addresses. 2 power 16 means it can locate, you can connect up to 65,536, that is 64 KB memory capability. So memory handling capability of a processor is decided by address bus. Data handling capability is decided by data bus. So it will tell you number of locations. It will tell you what is the data at each location. Byte ka meaning 8 bits. So now let's see this also address bus. One minute, I'm just uploading the slide. Okay, so now let's discuss about the address bus. What happened? I'm not serious, sir. What happened? I'm seriously searching for a file. I'm not serious. I'm okay. I'm fine. I'm absolutely fine. I'm not looking happy. Okay, let me laugh a little more. Actually, I'm searching for this. What we problem is, no, I'm not serious. You want me to be serious? I can make it serious. Okay, maybe I'm looking serious. Okay, no problem. Thank you. Something is fishy. Okay, let me laugh little more so that you feel more happy. Right. See, the problem is actual problem. Maybe the reason like this is this part is ready. I mean, whatever I want to upload, those slides are ready. But every slide when I upload, I need to do some cropping part that is not done properly. That's why little time is taking to upload. Please kindly adjust with that. So come to this address bus. Okay, let's see what is the meaning of address bus. So what is address bus? It is a unidirectional. Okay, I already told you that. It defines the memory handling capability of the processor. That also I told you already. If the address bus size is n bit, then we can connect up to 2 power n addresses. This point is clear? In 8085 microprocessor, address bus size is 16 bits. So we can connect up to 2 power 16, that is 65,536 64 KB memory. The lower order address bus is multiplexed with the data bus to save the number of pins. We can demultiplex with the help of a signal. I told you enable for the latch, now that is name is called address latch enable. So see here, for example, you have A15 to A0. Okay, A15 to A0. AL is a pin only. Okay, in that you can classify this as higher order bit. Just now I told now, higher order is A15 to A0, and here I'm sorry, AD7 to AD0. Originally, this is the pins of 8085. Now, in this AD7 to AD0, again, you can divide this into this can be classified A7 to A0 and D7 to D0. These pins are same only, but we use it for different purposes. Okay, happy? So A15 to A0, AD7 to AD0, A7 to A0, D7 to D0. Okay, so this is for your address and data. This is what we mean by multiplexing. Please happily feel free to ask me. No problem. Okay, so the next point. When AL is, see here, when AL is 0, latch will stop working. Okay, latch will stop working. That is, that lines will be used for data, but address will be latched. Okay, see here, I will tell you, just wait. See, this is your processor. Okay, what is that processor name? 8085. Okay, you have this. Now you have 8-bit latch. For that you give ALE. ALE is also one pin from processor only. When ALE is equal to 1, whatever here address is there, na, that will come here. Okay, after that what I will do, I will make ALE 0 and use these pins as data. Okay, you understand now? First I keep AL equal to 1 and address will be transferred. Then, cool, memory is having address now. So data comes. At that time, what I will use this for data, but by that time I make AL equal to 0. So this will not affect the address. Okay? Right. Okay, it is a 74 if you want ASIP exactly 74 LS 373. You can Google this latch. This is the 8-bit latch used in your 8085. It's not manually operated, it is automatically. Those things we discussed, don't worry. Just wait for some time. We are just going to the basic. Okay, Don't worry, what is ALE, how, when it will be 1, when it will be 0, everything we discuss. Then in 8085 microprocessor, see here, memory location is always addressed by 16 bits. See here, to the system you can connect two things. What are they? You can connect memory, you can connect IO devices. What is the meaning of IO devices? Input output devices. To any system you can connect two things. What are they? Memory or input output devices, like last lecture we have discussed that. Okay, so for 8085 you connect memory, it is always 16-bit address. Memory is always 16-bit address. But for IO, it is two types. It can be 16 bits, it can be 8 bits. If you use 16 bits, it is having a technical name called memory mapped IO. That is, IO is also treated same as memory. Suppose you have 64 KB na, in that some 1 KB or some half KB or something will be separate, what we call dedicated for IO devices connection. Okay, this is called memory mapped IO. Memory IO both are treated in the same way. But there is another case called IO mapped IO. In that you use 8-bit address separately for IO. That is where computer will treat IO separately, memory separately. Later, please listen. Here we are just going through fundamental understanding. Later, when we discuss the interfacing of the memory and IO, we discuss very clearly there. IO is what is IO interfacing? Okay, which IC will help us? Everything we discuss here. Here, don't worry about what is the meaning of mapped, sir. So this terminology will be new. Don't confuse with that. Okay. Right. Next. No, that may not be related to this. This is actually for the processor. It depends. Okay, some may be having some what we call Arjun for that particular card is there na, its own operating interface may be is loaded in that memory part. Its BIOS or some kind of system program may be there. Okay, next. So the next one is what we call, where is that? Right, control bus. Right. The next one is control bus. So 8085 contain how many buses? 3 buses are there: address bus, data bus, and control bus. Now, what is the control bus? That is, whatever the lines, wires connected to the 8085 can be classified into any one of these classification. That is what we want to discuss. Okay. So here in the control bus, these are the group of lines some are in to the processor and some are out from the processor. These are individual lines, so they can be coming to the processor, they may be coming out of the processor. Okay, like ready, read, write signals. Okay, so this kind of signals comes under the control signals. So this is another control bus. It is a group of individual lines. That is, it can be used to activate one particular device in your control, what we call system microprocessor, or it may be used to give some external signals also to do some particular operation. Okay, so these are what we call control bus, address bus, and a data bus. And one more thing I want to say again here, don't worry to remember the things, you will automatically remember. Don't worry, when you are listening here, first concentrate to understand only. Okay, while listening itself, don't worry to remember how to remember this thing, how to remember 65536, all those things. Don't worry about it. First instance, always concentrate to learn, concentrate to understand. Right. So the now we will move to the next one, the important part of your syllabus, that is 8085 microprocessor architecture. That is our internal structure, block diagram, all comes under same. So let's start. Yeah, what is that silly question? What is the size of? There is no size here. These are group of lines. Some will be in, some will be out. Just 1 minute. I will show you what are those control signals. Why are you calling it silly question? Yes, all are serious questions. I am not laughing. Don't say again for silly questions. You are not laughing. You are serious. You people told I am very serious, so I am thinking seriously. Why I am serious? If the person is not feeling, if someone came and why you are dull, if you ask like that, okay, why are you so dull and all those things. So the people will really think that he may be dull. Am I really dull? What is the reason? Now he start feeling. Okay, similarly, when you said serious, I am now thinking why I am serious. Is there anything happened really? Okay, so let's understand. Yes, Manisha, you need to remember. You need to prepare both of them. There is nothing big here. It is a logical figure. I can draw it without seeing this also. Okay, you can also try it if required. In your gate exam, you need not draw anything, so nothing to worry. Okay, so don't worry. Listen here. It is just a logical representation. It is a logical representation to understand what your processor is having internally. Your processor chip is this much size. Okay, how that fellow is working, you should understand by opening and seeing. If you open and see, okay, you don't get exactly like this, but you can say logically its structure will be like this or its working will be like this. Okay, so when you see this figure, nothing to afraid. It is big boxes, that's all. Okay, in this every single pin I will explain you. Every single pin, everything here is will be explained to you. Don't worry about it. Okay, so now this is what we call internal structure of 8085. Okay, if you required, we can zoom it. Listen. Yes, all the 40 pins will be there. Shall we count for fun? Okay. So listen here. It is 8. Now you people said I'm serious. No, I want to make it fun. This is 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 32, 38, and 40. Finish. Okay. So we discuss everything. So in that, you know this already. This part is done. When you said, I don't know whether it is Goenka big or not, Pupul, but I want to say you one thing. Listen, I forget. Thank you very much for remembering one thing. Listen here. Sorry, this is the first thing we should discuss. Generally, I don't remember. Actually, it's not Goenka pick. It is made by Intel. Aditya. So it is the Intel released some data. Every pick is from that data. Whatever the opcodes and all those things, everything from that. Okay, so now the reference textbooks I want to give you. This generally people will say first. So Yeah, my notes will be sufficient. I can happily say that. But if you have, some people feel what we call formal way, they ask me, so I am giving that. So as you told me, 8085 microprocessor and interfacing by Ramesh Goenka. EK is 86 man. 85 is not there. Next, similarly, 8085 by Srinath is IIT Kanpur, I think. Very good book, this one also. Not Javagal Srinath. Okay. And IIT Madras, NPTEL. If you have time, you do this. Okay. But I need to give, I am giving you that. Lecture notes. This is also very good. They gave very much in detail about every instruction very clearly. So all these things will come anyway on our slide, more than that. Okay. Some things will be better in this, some things will be better in this, something will be better than this. Similarly, our explanation will be better for our exam. Right. So let's discuss this. Let's discuss this. So let me explain. See here, this I will discuss whole day today. This part only. Whole today I will be discussing this only. Maybe only some part, half part may be discussed today, half part maybe tomorrow also. So relaxedly we will discuss. Don't worry. Now one by first briefly I will explain what each box will do. What each box will do. I will explain it. Okay. So firstly listen here. What is this? It is the address bus A15 to A8 and A7 to A0. Okay, this is the address bus. Okay, now you can see data is both directions. Data can write and read, but address is unidirectional. Observation is important. So here, this in the computer internally, the processor will contain this kind of registers. What are the names? W. We gave the name. Processor don't know its name. We gave the name according to its location. We kept these names. Processor don't know. Processor will keep its name as 000, its name as 001, 010, like what we call your roll numbers. He will also keep every location will have one number according to processor. But for our understanding, according to its use or whatever ways, we kept some names for them. So what are the names for them? WZ register. Okay. So you can keep your names also. Last four names: Rahul register, Shubham register. Like that, you can keep your own names. Okay. But everybody will keep their own names. Then programming will be difficult. So they made it universal by keeping the name W for this, Z for this. Like we keep our politician names for bridges and all those things. Similarly, for registers, they kept some names. Your W, Z, BC, DE, HL. All these are bracket 8 is there now. What does it mean? It is a 8-bit register by everything is a 8-bit register. Everything is a 8-bit register. Together you can mix it in the sense you can combine it and use it as a 16-bit register also. But now you understand what is the meaning of 8-bit processor. Its registers are also 8-bit in general. Its data handling capability is 8 bits. It is having a data handling capability. This bus structure, everything is of 8. It is 8-bit internal bus. What is the meaning of bus? You understand? It connect everything. Okay, one block to another block. To connect communication between one block to another block can be done with the help of this bus. Yeah, every register is 8-bit means here you can see 16 is also there. But most of the registers, all general purpose registers are 8 bits only. Okay, Shivam. Right. So you see here, let me strike off this part. This is a register selector. Okay. Then see here, what is this? Stack pointer. I will explain everything. Today we discussed that. Okay, please listen. Most of the cases it is true ASIC. This is program counter. This is increment, decrement, address latch. Okay. So please listen. I will explain everything one by one in detail. Don't worry. So this is the total register bank of the your 8085 processor. So generally these 16-bit registers are used to store the address. Why to store address, sir? To implement a concept of pointers. What is pointers in your C language? You should remember the definition, classic definition of pointer. What is pointer? Pointer is a variable which stores the address of another variable. Okay, so to point the memory, we use it. What is the use of pointing a memory, sir? I will tell you, because some people may be new to this terminology. Listen here. Why to point a memory? It will be easy to access. So suppose you store x equal to 2000. In 2000, this blocks are nothing but memory. 2000 address, you have some data. Some data is there. Next, I want to access 2001. So I should not write every time 2001, 2002 like that. What I will do is I load x with 2000. Next time I do x equal to x plus 1. Then where I will go? 2001 I will. Next I will do 6x equal to x plus 1. Then I will go to 2002. So every time I need not write the new value, automatically I can increment the variable which will go to the new location. So that is the advantage of storing address in a variable. That those concepts can be done with the help of this stack pointer and also your program counter. What is stack we discussed, don't worry, right now. Okay. Sir, you are saying everything we discussed. Okay, definitely we will discuss, don't worry. I don't leave any single point uncovered. Every single line in this figure, you will be knowing it clearly. Okay, now listen here. So this part, let me strike it off just for our happiness. Okay, now come to this block. Come to this block. You have power supply. What is the voltage? Plus 5 volts and 5 volts, minus 5 volts. Okay, for Gopi by happiness, let's make it plus 5 volts and ground. Okay, this is for power supply. These are to generate the clock. Crystal oscillator will be connected x1 and x2. Strike it off. Someone asked me now how many control signals are there. Silly something question. So these are all comes under control signal lines, man. Okay. To reset the system, to reset out every pin, we discuss it. Okay, these are the timing and control signals. You want to reset the whole system, you can use this pin. To reset the external system, you can use this. These are used for memory operations. We discussed that. Status operations, address latch enable, read operation, write operation. You can see some are into the system, some are out from the system. System in the sense your processor. Okay. So it is used to monitor your clock. This is used to communicate with the slower. Everything I discuss clearly. So I'm not going through it much. Every single pin I will write, I will explain. Every single pin I will write, I will explain. Okay. So this part is briefly is done. Okay. Use a different pen. No, I will just erase it. Don't worry. Deep. Okay. You don't worry about it. I'm there. You know I'm very logical. So see here. Yesterday, last lecture, we discussed one thing. What are the jobs of your computer? Not 8085, any computer. What are its jobs? What are its jobs? From the memory, what it will do? First, generate the address. Generate the address, fetch, decode, execute, memory, and again generate the next address. Right. So I told you here earlier, address next instruction is to be generated every time. Here in this figure, who will do that job is called program counter. Program counter, after every reading operation, it will do BC equal to BC plus 1. BC equal to BC plus 1. It will auto increment, that is generate the address. Then computer, this system will go to that location, fetch the data and keep that in this register called as, what is the name technically called as instruction register. It takes the data from here and keep it here. Once it keep it here, via this, please listen, this is the bus who is doing that job. Once it keep it here, then this fellow will decode. Decode means understand what is the job to be done, understand what is the job to be done, and it will convert into necessary machine cycles, and it will give it to the timing and control signals, which will control all the system, which will activate a particular device and deactivate a particular device. That's why you see a lines are going, group of lines are going from there. Okay, so from here it will load it to the register. From register it will understand what is happening. It will understand what is happening, and then it will convert into necessary machine cycles. Then it will tell to the timing and control signals, get ready guys. I mean, which particular register is to be activated, which what is to be activated, what is to be deactivated, in a timing. Okay, first this add operation to be performed. Second, storing the result should be performed. Like that, everything is taken care by this part. Okay, so this is your design. Then here, to perform arithmetic and logical operations, addition, subtraction, etc., you have this fellow. Who is that? ALU. And to represent your result, you have flag register. How to represent? We discuss it. Okay, then we have two registers to do this job. To handle the interrupts, what is interrupts, sir? We'll come to that. Okay, we have different interrupts. This you have interrupt controller. For making serial communication, we have serial IO controller. This is very roughly I am giving you. Now I will give you one by one every single thing. Just briefly, I gave the meaning of each block now. Is it clear? Once you understand, this figure will not look complex. Please understand. Once you understand this, it is a very logical. It will not be difficult at all. Okay. Right. So this is the simple block diagram of 8085 microprocessor. So now listen. If you understand this, it is the easiest subject, as I told you earlier also. Now let's move further. Now, desktop micro controller. Right. Listen. See here. 8085 internal architecture is functionally classified into 6 blocks. Okay. To understand this figure, logically we can make this or break this into 6 parts. What are those 6 parts? Registers. क्या registers है हमारे पास? This part to register. This is also one kind of register. This is one register. This is one register. So half of the figure is done if you understand registers. Just take it and throw it outside. Okay. So this part is done. This part is what we are going to discuss here. In the first part. The second part is ALU. Then whole part is done. I mean Excel this. Then in the next part, we discuss the instruction decoder and machine cycle encoder. That's the meaning of this. Then interrupt controller, serial IO controller, and timing and control unit. These 3 blocks we discuss. So block wise, we'll be discussing one block. So first we start with the register. So all of them, okay, please understand one more point. all these blocks are internally connected by whom? Data bus. Who will connect them? Your bus, your data bus will connect all of them. Okay, or you can say simply bus. Okay, now let's start with registers. So the next thing we are going to discuss now is registers. So you know what is register? Registers are a group of flip-flops cascaded together to store the data is what we discussed in your digital. Now we are seeing the different kind of registers existing in your 8085. I mean based on its working operation. So in that registers. So registers are classified basically into two types. That is general purpose means you can use it for any general purpose. It can be for data storing, data writing, whatever, temporary results, etc. And a specific purpose. So for a particular special purpose only, we use these registers. In the computer, some registers are general purpose. They use you can do anything. Some are special purpose. Now, in that user accessible, and again we can classify into user not accessible. What is this user accessible and non-accessible business? Listen here. User accessible means you are the user. You are the user and I am also the user of the processor. So the particular user can directly access that register. That is, he can directly touch and feel in the sense that he can write the data or read the data with the help of some instructions. Then it is called user accessible. You understand what is the meaning of user accessible? The person who is writing the program is able to modify these contents directly or read these contents directly. Then it is called user accessible. If he is not able to directly access it, then it is called user not accessible. Yes, access denied. Only internally computer will use it for its purpose, but it is not given to your user. Those are user accessible and non-accessible. So out of the register shown in the previous figure, let's classify which are general purpose, special purpose, user accessible, not accessible, everything. So in that user accessible, in the general purpose user accessible, you have B register, C register, D register, E register, HL register page. Okay, and here user not accessible, you have W and Z and temporary register. Okay, and in the again special purpose user accessible contains, let me use better colors, your program counter, stack pointer, okay, and your accumulator. ACC means accumulator. And in the user not accessible, we have instruction register. You can also include this increment, decrement, address latch. These are not accessible to the user. User cannot watch, I mean, modify them, instruction register and all. So these things are done. So please listen here. SP means Superintendent of Policeman. right? Stack pointer. What is stack pointer? We discussed it. SP is the stack pointer. So now listen here. W is covered, Z covered, B covered, C covered, D, E, H, L, SP, PC classified, and this is classified, this is classified. So see, half of your job is done. I left this fellow. So let's come to that also. He is also user accessible. Another is called status or flag register. What is the another one? Status or flag register. Okay, so total registers can be classified into general purpose. Any special purpose is there. What is that special purpose? We discussed. How address is not accessible? I didn't get you. Which address? Accessible in the sense you cannot modify its contents with the instruction. Yeah, WZ is also temporary registers. Okay. So all your registers are classified. Status register. See here, flag register. Another name is status register. Okay. So all this comes. Now we discuss one by one again. This is one broad classification. Now we discuss again one by one. That is the meaning of each register again. Okay. So let's go back. If you want one more, sorry, one more thing. We'll go to that before that. So don't remember the things. You can remember also, not an issue, but not required for our gate exam. I mean, don't remember this whole figure. So this is your 40 pin IC8085. This is the processor, each pin description. Okay. So this is your X1, X2, where you connect the crystal oscillator. This is used to reset the system externally, serial output data, input data. These are the interrupts we are having. This is the bus from A0 to A15. Ground, power supply. See, very easy. See, up to this is already done. You can see. Up to this is explained. This we discussed it anyway. Okay. Trap is there to trap you. Yes. I also draw on board so many times. Now I have this choice. So why to waste your time? That I take this upload. Okay. So these are different hold, memory access, clock, reset the system, ready. All these things we discussed. VCC or VSS both are called as ground only. Sorry, not V. I'm sorry. VCC is power supply. VSS is ground. That is VCC where you connect the 5 volts and the ground. Okay, your voltage contains two terminals, positive, negative. Can I say like that also? Right. Now listen. One more thing. Yeah, there are different reasons will be there. Noise margin, etc. Okay, noise margin will be considered. Some delays will be considered to place which pin at which position. Okay, these are the DIP, dual in package ICs, which we read in the U shape like this. Diagonally means here and here, he mean. Okay, now come here. It is the same figure only, but logical classification. This part will comes under address bus. Control signals are these things. Some people ask me, okay, so this is a external acknowledgement signals. All these logical classification. This part, okay. So please understand the things. One thing I want to say it again. We have not discussed anything about it. Everything about it will be discussed. Okay, this is the your processor I am saying, but nothing is discussed in it. Just a few simple bus structure is discussed. Everything will be discussed. Okay, it's a variant in 8085. That's all. Your 85 only. Remove that A if you don't want. Okay, now the next one you are going to is registers. In the registers, first one is a general purpose, the next one is a special purpose. First, let's discuss what is the meaning of all registers one by one. That will finish off of your block diagram. So let's go. Already 1 hour completed. How time is passing here? One minute. Just uploading the slide. Time and tide. Some title is coming. What is that? Fast like anything. I think wrong slide uploaded. Right slide only. Yeah, right. You know, Arjun Reddy means your Kabir Singh. Arjun Reddy name is another in Kabir Singh in Telugu. Sorry, Kabir Singh in Hindi, Arjun Reddy in Telugu. Daily change your profile name so that it will be exciting. One day you keep hero names, one day you keep your teacher, one day you keep your star name, whatever. So let's come here. User accessible and non-accessible. I already told you, if a register is user accessible, then user can read or write the data in the register directly with the help of instructions. He will use the instruction to write or read the data in that register directly. If it is not pointer, program counter, increment, decrement, address latch. Except these remaining all registers are 8-bit only. Remaining all registers are 8-bit registers only. Now come to this GPRS. What is this? GPRS. Okay. So, general purpose register set. The name itself says anybody can use it like anything. Okay. For whatever the reason, you can use it. So, BCDEHL. Please listen. Chair register, 6 register. BC, you can see the figure if you want again. So, where is that figure? B, C, D, E, H, L. These are 6 registers. B, C, D, E, H, L are the user accessible 8-bit general purpose registers. Okay. What is the size? 8-bit, which can be used for any general purpose, like to store the data, address, results, whatever you want, whatever the general way you can use it. There is no specific purpose for this. Then they can be, please understand how the processor to be designed. You should learn this subject in that way. Think you are designing one processor. What are the things we should keep it in mind? Okay, how many registers, how many instructions, all those things will come into picture. Okay, so they can be combined to form 16-bit register pair also. Sometimes we combine B and C and form one register pair. We combine D and E, we form one register pair. We combine H and L, we form another register pair called H. We give it the name B, D, H for 16-bit. So to store some registers, some pointer operations, we combine them. Okay. So another name is there by default for HL register pair can be called as name M. Okay, it can be used to store the address of memory to implement the pointers concept, as I told you earlier also. Similar to BCDEHL, WZ is also your registers only. These are internally used by the processor to store some temporary results or memory address, whatever may be. These are also temporary registers, but these are not user accessible. User cannot access this W and Z. I told you here already. User not accessible. Okay. Where is accumulator in this, man? Ganesh, do you have accumulator in this slide? Whatever not there in the slide, that is not there. Okay, our friend accumulator will come. Temporary register is used to store second operand in some ALU operations. So sometimes listen here. 1 minute. Simple example I will give. External memory is having some number 30. Okay, so for your understanding. Accumulator is having some number 40. Okay, this is one register. This is one register. Some memory location. So I want to add this 40 and 30. What the computer will do? This 40 will be taken. It cannot keep it on the bus forever. Na bus will be used by some other people also, some other next thing also. So it will bring and keep it here. So I need one place for guest also. In your home, you keep one place for dedicatedly, if possible. If you have space, you keep it for guest also. Na? You cannot keep them in the line. So like guest room here, it is used to store the temporary results. It is used to store temporary data, temporary operands. One terminology is important. Suppose you are doing A plus B. Here A and B are called as, what is the name of A and B? Operands. What is this plus is called as operation. Okay, so to store the operands, you use this temporary register. Okay, it may be binary or arithmetic, leave that. That is not the required here. Operator is the operator is what is performed on a particular operand. Operator will decide the operation to be performed, whether it is multiplication or not. What I told? SP is not user accessible. When I told, man, I told wrong or what? Aditya, please read this. Is it user accessible or not accessible? Accessible. Okay. So don't go beyond these lines. Whatever I discussed up to that, understand. Temporary register is used to store the second operand in some ALU operations. Right. Next. After this, so some part is completed. So remaining part we discuss it now. These are not accessible, not accessible. Already this table you remember. You understand. So the next one. So the next slide. One minute, please. Again, I need to upload these things. So somebody asked me about accumulator. Their friend is coming. It is uploading. It is on the way. Please stay tuned. So let me upload it. What's happening, guys? Okay. So listen here. This is about your. So many people. Who is that? Who asked me about accumulator? I think Ganesh. Right. Accumulator is friend of your whole computer. Accumulator is like VIP. He will say, I am there for any operation. In your whole village, okay, for any settlement, accumulator will come. Accumulator is that much important. Okay, there are some operations, those secrets, like some operations cannot be done on other general people. It can be done only with accumulator. Some communication cannot be. He is not broker man. Some communication cannot. He is important person. Okay, some communications cannot be done with any other people. Some people don't talk with the other people. He will talk only with accumulator. Is the head. Okay. Some informations will be given to only accumulator. You only I will talk to accumulator. I don't talk to other people. Like that. Okay, so that much important. The accumulator can do is the your center of the center. Leader. Okay, your leader, your Raj, whatever you call. Okay. Now this is accumulator. So this part is done. SPPC not done. Okay. So we came to this one. Now come here. Where is that? Right. It is a special purpose. Listen here. Listen here. It is a special purpose user accessible 8-bit register. It acts as one of the operand in all arithmetic. Any arithmetic operation, it always says I am there. Okay, so one operand is in arithmetic and logical operations. Arithmetic means addition, subtraction, multiplication. Logical means your end operation or operation. Whenever you do all these operations, one operand. What is the meaning of operand? I told you na, is by default accumulator. In 8085, not every case. In 8085, one is always accumulator. Second is only your choice. It acts as a destination register in all arithmetic and logical instructions to store the results. So new terminology came, I will explain. Suppose you want to add x plus y. You need to store this result x plus y somewhere, na? That somewhere you need to store is some x. Here where you are storing the result is called destination. You can do x plus z, then also it will store in x only. You cannot do y plus z. This is the restriction in 808. You can do x plus y, x plus z. You cannot do y plus z directly. You want to do y plus z, first store z into x and then only you can do. Any transaction should be done via accumulator only. Unka commission dena chahiye. Okay, he is there everywhere. He is there everywhere. Most of the cases, except a few cases, some personal issues he may not involve, like copying, moving somewhere he may not involve. Otherwise, he will definitely come into picture. Okay, so accumulator is one of the operand in most of the operations, and also it will act as a destination. I already told you na, certain instructions which can be performed only on accumulator, but not on any other registers. There are some operations which you cannot be done by anything. Who can take it? Only accumulator can take it. Those are design is like that. Complement accumulator, etc. Those we discuss it later. So up to this, anyone having any kind of doubt, please ask. Feel free to ask me. Deep is there. Today he is not there. Clear? Everybody who are new also, feel free. There is Gopi, you are there. Like small, we discussed that some move operations, etc. All arithmetic, logical, he is there. Some data transfer operations, he may not come into picture. Pair means only 2 pair of 3 registers is wrong, Aman. Yeah, those are the names we gave Samir. That is BC, DE, HL. It is internal to the processor. We have given that. You cannot alter their names also. Destination is where you store the result. This is destination. If number of bits, which bits? Number of bits is not power of 2. Combinations is power of 2. Address bits need not be power of 2. Address bits can be 9 also. You have a memory with 9 bits also, 10 bits also. 1 KB requires only 10 bits. There is a 8085 microprocessor where 20 bits are there. Sorry, 86. It is not power of 2. Okay, addresses are power of 2. Address bits can be anything. After performing operation, result is stored wherever stored, that is destination. Correct, Bhartu? Very good. So, right, let's go. Let's go to the next register. Which register you want? Let me load PC. There is no any register, man. Deep, you are there. Good. Okay, PC, program counter. This is important. This is important. Listen here. Listen here. Why PC is important, I will explain. I told you earlier also, once you load the data, immediately my pointer should move to the next point. Yeah, accumulator is whatever we are discussing now, all are registers only. Everything we are discussing now comes under register only because it is having memory capability. There may be some variations. There may be some variations. Just wait. Just wait. Right. You, as you tell, load the data, increment. Next loaded, increment. Next loaded, increment. It's a kind of register. Actually, it's a counter, but as it is storing the data also, we call it as a register. Okay. So every time it loads, okay, every time one memory operation, one opcode fetch, one machine cycle, we call technically. Okay, one operation is completed. Then PC, there should be one fellow who generates the next address. Last lecture I told na truth, this flowchart wala figure. Generate the address of next, fetch, decode, execute. Those story I told na, generate the address of the next. This job is done by whom? Called as program counter. Every time, okay, every time one memory operation completed, next address should be ready. That is done by program counter. Okay, listen here, listen here. Let me explain you one small example. I want to write a program. Let me remove this. I want to write a program. Just for example, please listen. Such that program is at this location of 2000. There, I will give some data 20. My program is to go to some location 5000 somewhere and give this 20 to this location. Like he will pick up this data and transfer some courier service. Okay, this is the program I am writing. So here I will write the necessary opcode, operation code, we call machine code in ones and zeros to do this, for in a way computer will understand to do this job. How to make that ones and zeros we discuss. Okay, so now what happens? This is the job. This is one instruction. This is one instruction. In this one instruction, you have multiple jobs now. First job is what? First read the code. Read the code, understand the code, execute the code. After this part, what you understand is, after reading this, under fetching, decoding, executing, after completion of that whole, you understand there is one number here in the next location. You should take that number and carry it safely and keep it here. Computer will understand like that. Listen like a story. Okay, so computer has first job is to read this first. Read it is given a name of code fetch. Even it is a fetch, it will decode, it will execute, it will understand the program. After reading this, it will understand I need to go to next location. I need to read this data also. For that, we keep one name called memory read. It is reading this number from the memory and taking that and keeping it where? New location 5000. Why it is keeping at 5000? This is my example. This is my own example randomly located. Okay. So at the third job, what it need to do? That number is to be taken and safely given to this number. This is what we call, we can say memory write. Memory write. You understand or not? Okay, so one instruction can be divided into multiple jobs. One instruction can be divided into multiple jobs. Okay, what is your doubt, Gopi? Please ask. You have one instruction. Okay, this is one example randomly taken. What is that example I have taken is in 2000 location, I have some code. That code will tell that take the number in the next location and store it into 5000. Okay, please listen here. I am repeating again. Please listen. First, this is my job, simple job I am explaining. In 2000, I have a code. Computer will read this code. Reading this code and understanding this code is given one technical name, opcode fetch. It is given by computer, what we call processor. The name is opcode fetch. Once it does, it will come to 2000. It will understand what is the job to be done by the computer. By this, at this, it will do a decode execute. Decode also it will do here. Name is fetch, but it will decode also here. Okay, it will read this. It will understand what is the job to be done. Then what is the job it understand is I need to read this 20. I need to read this 20 and write it in the 5000. I need to read this. Read means you are reading from the memory to the computer. And now bring that 20 and write it in the memory. Memory is external. Okay, that is from the, it is not FD. FD is there here. F and D are mixed here itself. Please listen. F and D are here itself. Here itself it will understand because your processor is not what we call pipelined fully. Okay, F and D will be done here. This is the execution part. Okay, this part is the execution part of this particular instruction. Fetch may it will read. That is also one kind of memory read. Correct to it exactly. Okay, now you understand 1, 2, 3 example. These are just example operations. Okay, so all fetch read write. Please understand, read is done here. Here also it is read. It is also read only, but it is having a technical name called opcode fetch. Here you are reading the memory contents. That's why it is called. Here also you are reading, but it is a different situation where you are reading the code here. You are reading the code here. Here you are reading some number. Okay, that's why here this is also memory read. This is also memory read, but we distinguish this as opcode fetch. This as memory read. Okay. Yes, at 2000 location, we will provide the command, whatever required. So that command will be read by computer, then computer will understand on its own. The next byte is to be read again. Okay. Yeah, suppose there is a program already, please listen, this program is already present. You have made this program written already. Okay. At 5000, you are waiting with and 2001. This is already written in the memory. Okay. You loaded program counter with 2000 also. Okay. Opcode fetch contains generally fetch and decode both together. We call opcode fetch. Execution is the job you are doing. Here, what is the job you are doing? Take the 20 and write it here. That is what we call execution. Here, what is comes under execution is this last two steps comes under the part of execution. Correct. Okay. So our intention is not to discuss that. We discuss it clearly every machine cycle. But here, what I want to say is your total job is technically divided into parts or not. You understand this part? Some understand. Your total job is divided into parts now. Each part is called one machine cycle. What is the what is the meaning of machine cycle? Each job in the total job you divided into parts now. Each part is one technical name is machine cycle. This is one machine cycle. This is one machine cycle. This one machine cycles. This machine cycle requires some time now. Say maybe 5 microseconds of time is required for this machine cycle. This requires 4 microseconds. This requires 2 microseconds. Okay. Listen. Please listen. For example, 5 One instruction is there. Each instruction has multiple machine cycles. So for one instruction, in this example, we took 3 machine cycles. And in these 3 machine cycles, again, you can divide into necessary T states. What is T states? Time period of the clock is called T states. I am repeating, please understand. You have one instruction. That instruction is made into parts. इसको 3 part किया. Each part is called machine cycle. Again, that machine cycle is converted into time. With respect to time, we can say it is a T state. Is it clear? Forget about the previous all the cases. Okay. So everything we speak with respect to T state only. That is how many clock. It is the technical name we use for T state. In our counters, we call time period of the clock. Now that is nothing but a T state. So to do this job, how many clocks are required? We are measuring the time with respect to clock, not with respect to your seconds or minutes, not like that. It is with respect to clock we measure. To do this job, how many clocks are wasted, how many clocks are required. So this is what we call technical terminology. We discuss it very clearly, don't worry about it. Now come here. This is just to explain you PCs, please understand that. Now come here. Program counter. It contains the address of the next location to be accessed by the processor. Who is accessing it? Processor is accessing the next location that is already present. So generally what happens is address bus is there. Na? Program counter will give its value to the address bus. Please listen carefully. Okay, don't confuse. Any doubt, please ask. I am there. So please see. Program counter is there. Na? Contents will be given to address bus. Now PC is free. Okay, why it is free? Address is loaded here. Once it is loaded, then your PC will be done by PC plus 1. This is the job done in the computer internally every time. Generally, in a particular machine cycle, this is done in the first T state. This will be done in the second T state. In this part, any doubt, please ask. Originally, firstly, PC contains the current. See, 2000 is there, na? That 2000 will be in where? PC. Now PC will give it to the address bus. Then PC will be ready for the next automatically because address bus will take care of 2000. Then this step my PC will become 2001. Even PC changes, address bus will not be affected until the next machine cycle. Yeah, it is mostly almost common. There are exceptions, we discussed that. Yes, in the T2 state, it will contain the next location. Na? Next from where you need to fetch the data, that is there in the PC. That's why we call it contains the address of the next location to be accessed by the processor. Next who, next where, which location I should get the data. Yeah, every, not instruction, every machine cycle it will change. Okay. I'll come to that ready. Just wait. All your points are here in the slide itself. All your doubts are answered in the slide itself. See here. It contains the address of the next instruction to be accessed by the processor. It keeps the track or the sequence of the program. It will only, who will maintain the sequence? How computer knows in which sequence the program is to be executed? Program counter will decide that. You program counter ka value change kiya to computer will jump to any location. Okay. So your Google map mein PC is the destination. It is like a Google map with PC as the destination. Agar destination change kiya to you will be going to the new location. Same program counter is like your same in your when it is running. So please listen. In most machine cycles, what is the machine cycle? Ek job ka name. One job is one machine cycle. In the first T state, PC contents are given. Please listen. Don't ask until completion. First T state, PC contents will be given to address bus. Understand, listen to understand. Okay. So PC will be given to address bus. Then in the second T state, program counter is auto incremented by 1. PC will be on its own, it will become PC plus 1 to point the next location. That is, it is getting ready for the next mission cycle. Okay, now please listen. In some instructions, I think Kaman asked earlier, what is that? Is it true every case? No. In some instructions, like stack operation, where the next address is not in sequence, sometimes it may not be in sequence. In those cases, PCs may not be incremented by 1. PC may not be incremented by 1 in the second T state of the machine cycle. It may not be incremented every time. It depends on the program or instruction that when we discuss the instruction set, I will show that. Okay. Program counter contents can be altered to change the program sequence also. अगर हमको नया location जाना चाहिए तो you can keep PC with new value. You want to go to new location, keep PC or update PC with the new value. You can update. Okay. So this is what I told. This is most of the cases, not every time. There are exceptions for this. We discussed that. So now ask me, what is your Shivam doubt? T state is from fetch to program counter increase, right? T state is every clock is one T state. Yeah, it is a 16-bit only. Program counter is 16-bit. Wait. Yeah, it is a 16-bit. PC, SP, all are 16-bit. Good. This is a 16-bit. Address is a 16-bit size. Your address bus is 16-bit. It should store address. So address requires a 16-bit memory. Any other doubt? Every location is given by PC only. There are some exceptions. We discussed that. If you understand this, I can move to the next. Confused Shiva? Don't worry. This is the hierarchy. First instruction. Instruction ka machine cycle. Machine cycle ko n T states. That is total job convert into parts. Each part का time. इसका 5 time blocks चाहिए ऐसा. Yes, Rupul, you are correct. Is it clear, Shivam, now? One job is one instruction. Okay, it is made into multiple parts. Now each part is divided into n clocks. Each clock is 1 T state. Good. So now listen here. Most of the cases in the books also, they don't give this content. They generalize this is true for every case. I will show you it is not, as I told you now also, it is not true every case. PC will not be incremented every time. I will show you the exceptions. Okay. So let's move to the next one. That is when we discuss the instruction set. So the next. Not the data transfer, just to, it is like your pointer. Okay, you can say it is showing your next location, where to go. Computer ka, what we call, the way path will be shown by program counter. Path decider. Computer कहाँ जाना, next इसके बाद कहाँ जाना, like a map, Google map का destination. Once this is a block of data you need to access. First load with the start address, leave it. Automatically it will do total job. Because without program counter, you assume first byte is read. Next byte you should say again, go and read again every time you need to say. So path decider is a program counter. Destination, what is the path decider? Which path you need to go? Okay, let's move to the next. So let me give you some basics called stack. Listen. If I hope you know types of stack, but I know you don't know. Okay, so your LIFO pushpa, but I am saying la. Do you know bottom up and top down and empty stack, always filled stack? You know these things, right? Okay, if you know it, it is very good. If you know it, so okay. So what I am saying is the types of stacks is a general data structure content. It is not part of your 8085, but still I will discuss it in the doubt session tomorrow. Just for your general understanding, that is not required here. Okay, from bottom up or top down, all those things we discuss tomorrow. Okay, just leave it now. So what is stack? What is the meaning of the stack? What is this last in first out? Why not? What is the use of this? Let's take one example. Let's take one example. You are at your home. Okay, just let me explain you clearly. Just wait. Yes, we are discussing from zero only, Ritika. Any problem? Okay. So listen here. You are in your home. Okay, from home. Okay, the rule is like this. Uh, you started. You came to the destination one. Okay, you want to you need to come to this place. Okay, it is forget about computer. Forget about computer. Okay, we are speaking general case. General case. Okay, आपका you this is your home. This is your destination. There is only one path. Please think like that. Okay. So at this point, your friend came and he diverted you. He diverted you to go to new location. Okay. So from this location, okay, he want to take you to some Y place. Okay, you can go there anyway. Later you may go to this library. Let's go to movie first. Okay. Yes, we are in sync. So, but here suddenly you get another good friend. Maybe your I don't say you understand. What Anand Complex Arjun ji? You are from I think my place. You are our Jaunty Roads. Vishta, you are also from Kakinada or what? Okay, good. Oh, very nice. You are from my native place. Okay. Harish, just wait. Listen here. So, from your library, he took to movie. From movie middle, you got some what we call you want to go to restaurant. Okay. Listen here. Listen here. Just wait. Restaurant. You want to eat the food. Okay. So, Harish, your favorite food came, right? Nice. I'm seeing all new names, all names. So many people are there. Good. So restaurant came from restaurant. Okay, sudden job is there. Some you need to help some person. You went there. Okay, your job is stop that discussion. Please listen here. Stop the discussion. Come here. Don't divert. Okay. So from this, your job is completed. After completing the job, there is no other path. For example, you should go back, but you forget the address of the restaurant. If you forget the restaurant address of the restaurant, can you go there? So, so what I did is I stored these addresses. Please listen here. Please listen. I store these addresses. Please listen. Okay, three ways I gave. First time I seal this part. Okay, second time, 1 minute. First time I see this part, second time I see this part. Okay. So your here you can access from this side and this side also. Now there is a confusion. From here you need to go to 3 or 2. Please tell me here. Here you can access from this side, access from this side. Okay. You need to go to 3. In this case, confusion is there. Here, wrong destination you will reach. Here you see from here restaurant may bill pay here directly go to 1. Is it correct? After 1 go to movie. Movie is also over. Okay. So that is not correct. No? So from here you should go to 3. So suppose if it is blocked this side, you should access the data only from this side. First case, I can access both the addresses. In this case, I can access whoever comes. First I stored 1, 2, 3 in some place. First I can access 1, then I can access 2, then I can access 3. In this case, what is the advantage? I access first 3. Then I can go after this job, I will go to 3. Then what I will do, I will access 3 is came now, then I will access 2. Okay, 2 came out. Then I will access 1. Okay, this part is done and I will go to 1. And I will complete my original library destination. Maybe it is closed also, but I did my job. So here there is a requirement of storing the data or at least accessing the data. You should access the data. Whoever first who came in this case, 1 came first, 3 came in the last. Here you can access from any side, no restriction. This fellow is of no use for us because it is confusing. This kind of thing is called first in, first out. We call it as a queue in the data structures. Who came first, you should access them first. Some movie ticket line is there. Who came first, you should give ticket to that fellow. If you give it to the third fellow, people will fight with you. They will beat you. Okay. In that case, you should not go for a LIFO. Okay, they will kick you definitely. Okay, but in this case, what you need to go is this one. This is what LIFO. LIFO, it is called stack. Okay, LIFO or philo, first in, last out, or last in, first out, whatever you can call. Listen here, listen. Now you understand the purpose of the stack. Now you understand the purpose of the stack, yes or no? Good. Wait. And also, purpose of the stack you understand. Here, one more thing is required. You should maintain the order, right? Yes, Subra. Once 3 is read na, you should go to 2. Once 2 is read na, you should go to 1. So I need one pointer kind of person who points to the first location. Yes or no? First read 3. Once 3 read, go to 2. Once 2 read, go to 1. So this fellow is doing the pointing. That pointing job is done by, in your 8085 microprocessor, in your 64 KB of memory, some part is dedicated for this kind of operations. That is nothing but stack memory. Who is doing this pointing job is called as stack pointer. Now you understand the meaning of the stack pointer, everybody? So here the names are fancy names, very posh names you can use, but understand the things, it is very easy. Okay, whether it decrements or increment, don't worry. Like that I told you, tomorrow we discuss the different types. So that is incrementing, decrementing, up, down, bottom of all those cases. In 8085, it is a bottom up or auto decremented type. Okay, you don't change. Here also, you need like program counter. Once read, automatically it should do this. What is your confusion, Asif? Then I can clearly explain you that thing. What is that? You cannot change it. If you can change it, this is like this. Okay, see here in the first memory, please listen. First memory, first memory you can access from any point. Random access also possible. 1 2 3 may you take 1 first, 2 first, 3 first, it doesn't matter. So from restaurant, see here, simple example, home to movie. In the movie you went to what? Restaurant. In the from the restaurant you came outside, okay, some washroom, okay. From here you should go to restaurant, complete the food, then go to movie, complete it, and go to home place and do your original job. Okay, please listen here, please listen here. Okay, so once when you are coming from here, because to go back, because you are like Ghazni, you don't know, you are like just like a Ghazni. Whenever you come out from this place, you don't remember this. Okay, so to know where to go, like Ghazni takes photo, you should take this number and throw it into memory. From here you came, while coming from went to movie, you took the tickets and all. From there you should again throw this memory into memory and go to restaurant, because you should know where to go back. From this it is completed, you have eaten your while you are eating food, some incident happens, you went there, you are helping them, throw this. Okay, okay, so now every first what you do, first you stored whom, one you stored, first entered is one, last entered is three in the memory. In the memory 1 2 and 3 you have entered, but when you are coming back, whom you are taking first? Who entered into last should be taken first. So from here, first I should go to restaurant, who I left first, last left person will be taken here. Restaurant go, you eat your biryani, go back, watch your movie, go back and go to library. So that's why it is LIFO, last in first out. Yes, you can go back directly also, but your food is wasted, your movie will be wasted. Asif, understand? Yeah. So this is not, see here, this is not the case every time. Nishita, just wait. Please listen, please listen. Wait. Your memory will not be accessed every time like this. I just gave one example for stack. Okay. If you are in the queue, you are in the movie theater. Okay. You are taking the tickets. First, one came first, second, two came first, three came first. So I give ticket to third person first. Then definitely these two people will kick you like anything. Yes or no? So in this case, this structure will not be used. In this case, we use queue, first in, first out. Sometimes what queue here, whoever is VIP for me, I will give permission to him first. Priority is there, all those things are there. Then you can come to any place, go take any place of your whomever you like it first, take that first. This is a random access. You can access from front, back, middle, anywhere. Here you can access from backside only, here you can access from front side. This is not related to your 8085. It is generalized way to access the memories. So what I will do, what your 8085 manufacturer made is what not a manufacturer. As a programmer, what you do it is wait, out of 64 KB memory, okay, we dedicate some portion for stack operations. Okay, stack pointer points top of the stack. Okay, so just wait. Okay, I will answer to everyone. Don't worry, just listen. Now taking the data process in queue and result in reverse. Okay, see, queue is completely different. Okay, and stack is completely different. Queue is F5 FO. Input is always first in only, because once you give it whoever you give the input, that is first in. How you are taking the output now, that will decide whether it is queue or stack. So people will come like this only 1, 2, 3. Now after coming, you are taking 1 first or 3 first. That will decide whether it is queue or stack. Entering is same. Okay. Now what is Nishita doubt? Wait. Stack pointer and PC. PC is for every single operation. PC only used. Stack will be used in some cases like interrupts, etc., where this kind of jobs comes to the computer. When computer is doing one job, in between some interruption comes, it goes to some other job, or it is doing recursion kind of program in your C language. You do it 5 into 4 into 3 into 2 into 1 kind of program. Recursion we call factorial programs and all. This kind of cases may stack will be useful. See here, I will explain that, just wait. So 8085, you understand, some location will be used for stack. Stack is always LIFO only. Stack is always LIFO only. Okay, Harish, please see here. What is your doubt? We just go through it. You can watch recorded part also. Don't worry. Anyway, class will be done in 10 minutes. Then you can watch it. Not an issue. If not 10 minutes, maybe I told already. I may extend the up to half an hour. It's gone, man, Alcha. Done. Okay. So, any other doubts? Ask me. Any other doubts? Please, one thing, listen. It is a general example, not related to 8085 at all. It is a general example. Okay. How you use stack, once we use it, then you can understand. Don't worry about it. We will use the stack later, then you can understand. So Rohit, after some process, it will come to main program. Yes, sir. Okay. After n number of cycles, it will, wherever it starts, it will end at the same. Okay, Sushil. So generally people will say, what is LIFO is last in first out, FIFO is first in first out. Okay. Where to use it is important. Simple program. You want to find factorial. I am showing you. See here one example. How to find factorial is you call a function f. So f of n. Okay. What it will do is n into n minus 1. It is general. I am not saying microprocess. Okay. You have a function f of n. What it will do? N into n minus 1. So what I will do is I will call this recursively until n becomes 1. I will call this n number of times until if n equal to 2, I will stop. So first I will call it for 6. It is not equal to 2. Call that function again. 6 into 5. Call it 4, 3, 2, up to 1 it will do. Once it is done, it will give the answer. So when it is coming back, first it do 1 and 2, give the result. 2 and 3, give the result. This into 4, give the result. This into 5, give the result. This into 6 will give the final result. This is what we call recursion in the program. Okay, in 80, in our discussion, it is not required. Generally, I am saying. Okay, just wait. So now come to our 8085. This is general discussion. Thank you, Asif. Let's dive into processor. Right. So here, see. So first thing I want to give you stack pointer. Stack pointer contains address of the top location of the stack. Now you understand, right? Okay. Next one is the status register. I will come to that. Just leave it. Now, I mean next only. Next one is increment decrement address latch. It is used to increment or decrement 16-bit data. Your program counter, everything will be increment because it is 16-bit now. To increment that ALU cannot help. Who will do it? Increment decrement address latch will do it. Because your processor ALU is 8-bit capability only. Address incrementation, all these things will be done by this way. Okay, now listen here. What is status register? What is status register? Wait, just wait, Sushil. It is used to indicate status of ALU results with flags. What is this new terminal? What is flags, sir? What is status, sir? I will explain. Don't worry about it. Just wait. I will explain it now. Okay. So status register or flag register, both are same only. Why they are used? Let me explain it. I want to implement one program like this. I'm just explaining with the general example. See here, count equal to 100. Decrement count. If count not equal to 0, do a equal to a plus 1. Some job, some simple program I'm writing. Else, 1 minute. And go to X. Else, stop. What I'm doing is I'm just giving one random simple example. When count equal to 100, store some number, any number. Okay. If x equal to 100, x equal to x is the location, for example. X is some location. At this location, what is the what I wrote? Decrement count. Make it 99. If it is equal to 0, okay. If not equal to 0, what to do? Initially, whatever may be the a, add 1 to that. Okay. And go back to x. Decrement, add 1, go back to x. You do this job until count not equal to 0. When count becomes 0, this line will fail and you stop the program. Okay. So how computer understand this? How computer is understanding is computer should check. There should be some person to check this. Whether count is equal to 0 or not. Similarly, whether count is positive or not. Like that, few conditions of your result after some arithmetic operation will be indicated in a register called as flag register. Not only this, okay, whenever it is a greater than b, do something. Okay, these are called decision making. Okay, what is compactor, Sora? I didn't understand. This is just one example. So when count equal to 0, your flag, 0 flag will become 1. I will show you that. Okay, comparator. Comparison, when a greater than b, do this job. When a less than b, don't do this job. How computer will decide a greater than b or a less than b? It will subtract and check whether it is positive or negative number. If a greater than b, go there. If a less than b, go here. So for computer to understand these things, we use one register called flag register. Now I will explain that. Just wait. Don't think it is complex. It will be easy only. Just listen. This is what we call 8085 flag register. What is this? There is one register which contains 5 useful bits. Remaining bits are unused. Don't care. Okay, in that first bit will indicate sign. What is that? It will indicate if your result is -1, if it is positive, it will indicate 0. Don't see this. Okay. If result is negative, it will indicate as 1. If result is positive, it will indicate as 0. What 0 flag will tell you? Flag is the name for this bit. Okay, flag means it will not be our flag. Okay. So what 0 flag will do? 0 flag will tell you whether result is 0 or not, like these kind of cases. After doing some arithmetic operation, whether your result is 0 or not. If it is 0, it will make it 1. Okay, otherwise it will make 0. Is it clear? What is 0 flag job? 0 flag is set if the result of an instruction is 0, otherwise it is reset. It is like a flip-flop. It is just like a flip-flop. Okay, it is not used. Now auxiliary carry. You know auxiliary carry na? When you add two numbers from third bit to fourth bit, if you get a carry, then it will be indicated here. Very good. This is not used. This will tell you your result parity is even or odd. If it is even 1, odd 0, or 0. Last bit will tell you whether your result is having carry or not. So let's take one example, then it will give you better clarity. So let's take the example. For example, today no single question we have done. I think first time. Right. So I want to add this. What is 28? 28 means 0010. 8 means what? 1000. 49. Hexadecimal, man. Hexadecimal. 1 0 0. 1 plus 1 is how much? 1 plus 1 is sum 0, carry 1. Okay. Then 1 1 1 0. Now please listen. Carry is 0. Now what is the carry flag? After this, carry flag will become 0. Listen. Carry flag is this bit. Okay. Sign flag will be equal to 0. This is sign flag. 1 2 3 4. How many? Parity is even or odd? Parity is even, so 1. 0 flag will be equal to 0. 0 flag will be equal to 0. And auxiliary carry flag will be equal to 1. Why these are used? These can be used to write the programs of decision making. To write the decision making programs, these flag bits can be used. You don't need to do this automatically. Your processor itself, when you do any arithmetic operation, it will make these things. Whenever you do any arithmetic operation, computer on its own, based on the result, it will modify these bits, which can be useful for us to implement this kind of programs. We may write the program, if carry equal to 1, do this, carry equal to 0, do this. Parity, even parity, odd parity, Ganesh. And I told you in the communication systems, in the digital, I told you, na, parity checking. Whether the data transmitted and received is of without any error or not, for that we can check it. Very good. So now come here. What is the use of don't cares? Means they are not used people. That is the meaning. It is having only 5-bit flip-flop. I mean 5 used conditions. Remaining are unused. It is of no meaning for us, Sushil. Okay. Latch is latch only. If nothing is specified, we take it as an active high only, Sushil. Okay. This is the format they followed. That is, the designer who made it has used this format. Okay, he might have some distance conventions, whatever maybe, for to load this data. He may feel this is convenient for him. Okay, so this is the format followed by manufacturer, not me or not some logical. Okay, manufacturer can place a particular bit in a particular location. Mostly he will calculate the delays. Yes, Sushil, don't worry about that discussion. I already told you, nothing specified. Take it as active high. So now everybody see here what is the meaning of sign flag. Sign flag is if sign flag is negative, if s equal to 1, that is it copies MSB of result. Please listen. Computer don't know whether you are operating signed operation or unsigned operation. Nothing. Computer don't know anything. The order is mandatory. That is as per manufacturer. This order, Gopi. Computer don't know whether you are doing signed or unsigned. He blindly it will copy it. It is you who will use it. You may use it as a signed representation. If it is valid, we use it, otherwise we neglect it. Okay, so zero flag will be 1. It will indicate when result is 0. Okay, it is indicating the status of your result now. That's why it is called status register or flag register. Whether the result is 0 or not, result is positive or negative, all these things are indicated by him. Okay, so that's why this fellow is just nearer to the what we call ALU. You can see flag register is just nearer to the ALU only. ALU will modify these bits. He will make it. So I'm taking extra time as I promised you. I mean, as I told you earlier, I'm taking little extra time. Okay, is it okay? Fine for you? So that we can effectively discuss more number of things. Thank you, guys. So now, any doubt in the flag register, please ask. I think someone, Sushil, whatever the doubt you have, please ask me. Please understand, every student should understand the question properly. No hostels are there, man. Gopi, you have hostel? Oh, you are staying in hostel? Keep this as 7 to 9:30, or take your mobile and eat parallelly. Zero flag indicates whether the result is 0 or not. Okay, fine, Sushi. Rahul, is it clear? Zero flag will tell you result is 0 or not. If result after some addition or subtraction is 0, it will indicate, like a counter operation I told. Is it clear, Rahul? So these are decision making may they will be helpful for us. Okay, if this condition is true, go there. If this condition is not true, go there. Ah, not more than 9:30. Even I also want lunch and sorry, dinner and all. Okay, not every day. It depends on the topic we discuss. So tomorrow also, even the name is doubt session. We will be discussing the class only because we discuss only theoretical part. Now let's continue that. According to your football language, Asif. Right, correct, Amitabh. Okay, let's move next. Okay. I hope it is. Listen. The next one we are going to discuss is ALU block. What is ALU block? Arithmetic and logic unit. In 8085, ALU contains arithmetic and ALU contains arithmetic and logic circuits. What? Okay, ALU contains these things: arithmetic and logic circuits. Accumulator comes under part of ALU. Temporary register is a part of ALU. Flag register is also part of ALU. All these things will take care of your. These are helpers for your ALU. Okay. In 8085, what are the arithmetic operations directly available is addition, subtraction, increment, decrement. This computer can do only these things. Multiplication it cannot do. But you can implement multiplication by multiple additions. Yes, Bhargav, your doubt is correct. By multiple additions, you can implement multiplication. By multiple subtraction, you can implement division program. So directly these are not available in 8085. Only addition, subtraction it can do, increment, decrement. It is 40 years back, please think like that. But still it is a powerful, it can do so many things. Next, logical operations include AND operation, OR operation, XOR operation, compare operation, complement operation, and rotate operation. What is compare, what is rotate, we discuss it, don't worry. Right. So few blocks are done. Next block we are going to discuss is interrupt controller. You have the energy. Thank you. Right. Good. So let's move to the next one, interrupt controller. Interrupt controller. It is used to interface external interrupts to the 8085. Thank you. Just listen here. What is interrupt? What is interrupt is when I am explaining things, you people comment, then it is an interrupt. Right? I will divert. I will answer your comments. I will come back to the explanation. This is a simple example of interrupt. So similarly, when computer is doing something, if some interruption comes, what computer should do? Sometimes, please see, when I am doing some job, I ask you, please don't comment anything in between. You accept it? So that time, I am masking you people. I am masking you. Masking means I am just saying that even you comment, I don't read, don't comment it. Okay, that is what we call ignoring, masking. That is for the basic type of interrupt. The next one is called vectored and non-vectored. Say you are in your home studying very seriously. Your friend came to you. Okay, he came. So when the particular friend came, every time that fellow came, you went to same location. If this fellow comes to you, your mother understand they are going to movie. Okay. If this ex-friend is coming to your home, immediately mother understand, go movie ja rahe this week. Okay. So mother is like processor. Okay. She is understanding that where to go. You people definitely go to there only. Okay. This is called vectored. When interrupt occurs, you are definitely going to only one location. But there are some cases, interrupt occurs, but after interrupting, okay, you understand, okay, let's go. Then you ask where to go. Go to some random place. I will tell the fellow who came here, he will tell that where to go. There is no direction initially. I mean, after interrupting, I will tell, let's go here. Okay, this is a vectored and a non-vectored. This is non-vectored. Vectored means direction. Non-vectored. What is interrupt? When computer is performing some job, some external request occurs to do its job. To do its job. Don't see these definitions. Understand? When computer is doing its job, external request comes to do its job. To do its job, that is called as interrupt. Then computer will stop its job, come here and do the job, and come back and continue. This is what we call interrupt. Okay, so whatever I told in the stack, this is the best example to understand the stack. As I told earlier, you are in the home, went to movie, from the movie went to restaurant, from the restaurant you went to some washroom, from washroom come back to restaurant, eat it, and come back to movie, complete it, and go to home, and go to library. Okay, here every time you move, you are a Gajini, you should store the result address first to come back to the same. Every time you are moving from here, you take a photo. Mobile leke, you should take the photo. Latest Gajini. Okay, so take the photo, go. Take the photo, go. So which photo is last in your mobile? That is the where you need to go back. Okay, so please listen here. This kind of cases, this is nothing but interruption only. Okay, these are nothing but okay. Vector and interrupt are two type of interrupts. That's all. Okay, just wait. So this is nothing but interruption only. In this interrupt, stack will help us. Now you understand now where stack will be helpful. Computer is seriously doing some job. Some external interrupt occurs. Computer go there, service it, come back to the same. For that, it should store this in stack only. Return path. To remember the return path, we use stack. Okay, now come here. It is used to interrupt controller is the box used to interface external interrupts to the 8085. Interrupts can be your IO devices can be interrupt. Your printer is an interrupt. Okay, it can be like a printer. Print the job, print it. I want this. Okay, something your everything any external device is an interrupt. So some job is done. Suddenly power is gone. It will send one interrupt. Power gone. Immediately take the backup. Okay, all this comes under interrupts. Okay, so it is used to interface external interrupts to the 8085. When external interrupt occurs, 8085 completes the current instruction. Save the, please listen carefully. It will complete whatever the job it is doing. It is suppose reading a book. It will let me complete this page and come. It will ask like that. It will complete that page. Now what it will do? Save the program counter. Why it is saving program counter by? Why it is saving program counter? Because this fellow is only having the address. To come back, this what is that? Biryani, whatever we have taken now, washroom, okay, restaurant, movie. This is nothing but program counter will be having that. Address is there with a program counter, so it will store this program counter into stack and sends interrupt acknowledge. Okay, bye, I am coming. Okay, acknowledgement is given. You are talking, okay, you are doing some job, so interrupt occurs. Okay, you have given acknowledgement. Okay, I am coming. Right. Okay, I stored something. I mean, stored this address and I am coming. Then the particular ISR. See, immediately you get this doubt. What is this ISR, sir? It is like looking new for me. What is this ISR, sir? Okay, these are the things where you people stop microprocessor. New terminologies, new words will come, which will make the things complex. Okay, it is interrupt service routine. What is the meaning of ISR? Interrupt service. You understand? I typed this today. It took me around 2 hours only to type this story. I have DTP operator. I can ask him to type, but the problem is I don't know whether he can type it in my required format or not. For me, I know only the problem here is I have someone to help, but only I know how I need it. So there is no alternative. I only need to type this. Okay. If I write everything here, it will take 3 hours class. So now listen here. When external interrupt occurs in 8085, completes the current instructions, save the program counter contents in the stack, and sends interrupt acknowledged, then the particular ISR will be executed. What is ISR, interrupt service routine? Again, some people have this doubt also. What is interrupt service routine also? I will come to that. Just wait. I am there. Okay. Interrupts are generally classified into maskable, non-maskable. Maskable means ignorable, non-ignorable. Okay, you are talking to phone, you got some call. Okay, another call, whether to respond or not respond. This fellow neglected here. Okay, masked. Or I take one example. I am explaining this, whether to respond to your comments or not respond to comments. Then vectored, direction is there, not there. Priority. You know, life is your life is full of priorities only. So two people came for your help. Whom do you help is a priority. Same for interrupts also. N number of interrupts asks computer. Now you understand what is the use of priority encoder. Now you understand what is the use of priority encoder. N number of jobs comes to computer, but computer responds to only one job. That is based on priority. So designer, as a designer, when you design it, okay, you should keep some priority encoder to give high priority to one interrupt, least priority to another interrupt. So this is the basics of what we call interrupts. Tomorrow we discuss the remaining things. Just wait. Let me give you a few things. 1 minute. Just 2-3 minutes. I will finish it. See here. These things we discuss in the interrupts. These are the interrupting trap 7.5, 6.5, 5.5, INTR, INTA. All these things tomorrow we discuss. Thank you, but these things, these are comes under interrupt. Okay, just I gave what is the meaning of interrupt. Tomorrow we discuss what is the interrupt sources of your 8085 computer, what is the meaning of each interrupt, what is the meaning of RST, what is the trap, everything we discuss it tomorrow. Okay, just let me upload one more slide, then we can close. I mean that definition of vectored and non-vectored. You can read the slides after 2 hours, so you can understand for revision. These are the definitions for your understanding. Maskable, we can mask the interrupts. Mask is nothing but an AND gate. We make this 0, even interrupt occurs, you don't read it. Okay, vectored and non-vectored. Already we addressed destination is fixed, it is vectored, not fixed, non-vectored. Priority, high priority. This point we discuss anyway tomorrow. I'm not going to discuss it today. What are the 8085 interrupts? Everything we discuss it tomorrow. One more thing, listen. Some people might have the doubt with what is ISR. What is the meaning of ISR? What is the meaning of ISR? Interrupt service routine. It is a program to be executed. Just wait. Executed when interrupt occurs. Okay, see, this is the fancy name we kept for the program to be executed when interrupt occurs. Program is nothing but job to be done. Say, when that interrupt occurs, you need to do some job, na? You need to do some job. That job is written in the form of program. That program name is interrupt service routine. So when interrupt occurs, what you do? You will execute interrupt service routine. Its address is given by vector address. Is it clear what is the meaning of ISR? ISR is nothing but when interrupt occurs, the job you need to do means computer need to do is given by, like printing, right? Correct. Is given by ISR, interrupt service routine. It's just a program to be executed when interrupt has occurred. Right. So anyone having doubts, ask. Otherwise, you can end the class. Abhinit, what is your doubt? Let me check. Sir, one doubt. If it is maskable, then it can or cannot be. Mask and vectored are exclusive. There is no relation between them. Sushil, is any doubt? Yeah. ISR is the program. ISR is the name we kept for program only. ISR is nothing but program only. Okay. When you are writing, when computer is doing original program, interrupt occurs, it will go to the location, complete ISR and come back to original program. Yes, correct. Current program counter will be stored in stack. Rohit. Any other doubts, please ask. Tomorrow, please listen. Tomorrow, regular session only. One day we take, let me clear the basics first, then we can discuss problems. Tomorrow is not doubt session. Okay. Yes, Sushil. Good night, Shivam. Thank you. Good night, all. Double E, Aishwarya, it depends on what we call. It depends on our basics. If you are good with signals, you can understand communication. It is a little vast, but not difficult. Okay, Sir will teach you best. You can understand the rest. Good night, Shubhratri. What else? So tomorrow, 1 minute. Tomorrow, I think, 3 p.m. Any Telugu students are there? In YouTube, I am taking one class regarding 2021. I am taking. This is also free special class with them. One Bangla class I need to learn from you, Asif. Then I can take. It'll be very good. Odisha also. Yeah, I taught some batches. Yes, sir. Doubt session. Yes, it has a doubt session. Which I know it.